everyone, and welcome to another deep dive. We're talking computer vision today, how computers learn to see just like we do.
It really is fascinating.
Right. Like, think about it. Self-driving cars,
Absolutely.
medical diagnoses, even
Oh, definitely. Or even...
that thing where you unlock your phone just by looking at it.
Exactly. It's all image recognition.
Yeah.
And we've got some seriously cool research to unpack today.
And you know what I love about this? It's not just about, like, computers recognizing squares and circles anymore.
It's true. What's fascinating here is that it's not just about computers recognizing basic shapes and colors anymore.
Right.
We're talking about understanding complex scenes.
Yeah.
Relationships between objects.
Exactly. Wait, how did it even do that? Moments.
Yes.
So we found this paper, and you know how sometimes these research papers can be a little,
A little dense.
yeah, a little dense, a little robotic almost.
Laughs. Yeah.
But this one's actually kind of a fun read, and it's all about something called a vision transformer.
Yeah, the paper is titled, "An Image is Worth 16 by 16 Words.
Yeah.
Transformers for Image Recognition at Scale."
Catchy, right? But, okay, 16 by 16 words is the AI writing poetry now or something?
Laugh, not quite poetry, but it is about language in a way.
Okay.
Imagine you're trying to describe a picture to someone,
Yeah.
but instead of using words, you can only use these tiny squares, like a grid,
Okay.
to kind of get your point across, to explain what you see.
Got it.
Each square is 16 pixels by 16 pixels.
Okay.
And that's how the Vision Transformer, ViT for short, processes these images.
So it's like, okay, I'm picturing like Instagram, right? Like it's dividing the picture into a grid and trying to figure out what's going on in each little square and then how they all go together.
That's a great way to put it. And this is a big departure from the traditional way that computers see images, which relies on something called convolutional neural networks, CNNs.
CNNs, I feel like I've heard that one before.
Yes.
Yeah.
CNNs, it's like the big,
They're kind of the heavyweights of computer vision.
Exactly.
They've been incredibly successful.
Okay.
But like anything, they have limitations.
Okay, like what?
So think of it this way. CNNs kind of analyze images bit by bit, looking for things like edges and textures and patterns.
Okay.
They're really good at recognizing features.
But they struggle to understand the relationships between those features, especially over longer distances in the image.
So, like, it might see a beak and some feathers and wings, but not get that it's all a bird.
Exactly. It's like trying to understand a sentence by only looking at the individual letters.
Right. You'd miss all the context.
You miss the context, you miss the meaning.
Okay, yeah, that makes sense.
Right,
So that's where this vision transformer comes in,
That's
right?
right.
It's like, okay, let's try something new.
Exactly.
You mentioned attention. What is that all about?
Right. So instead of painstakingly going through every single pixel,
Yeah.
ViT says, let's focus on what's most important here.
Okay.
It uses something called self-attention to figure out which parts of the image are most relevant for the task at hand.
So it's like the AI is paying attention in class, but to a picture.
Exactly.
Instead of zoning out.
And this is where those 16 by 16 words become crucial.
Okay.
Remember how we talked about ViT dividing the image into these little squares? Each square like a word
Oh, boy.
with, visual meaning.
Got it.
And the self-attention part helps it understand how those words relate to each other, just like we use words to form sentences.
Oh, that's really interesting. So it's like its own language, but visual.
Exactly. It's learning this visual language.
That's so cool.
Where each patch is like a word.
So does it actually work? I mean, is it better than the CNNs?
You might be wondering
I am.
if this new approach actually outperforms the old methods.
Right.
And that's where things get really exciting, because they put ViT head-to-head against some of the most advanced CNN models out there.
Okay. And don't leave me hanging.
And the results were impressive.
Give me the highlights. What were they testing these things on?
So they used several standard image recognition benchmarks.
Okay.
Things like ImageNet,
Right.
Sci-Fi 100, VTab.
Right. Which, for anyone who doesn't know, these are all just like massive,
Those
huge
things.
libraries of images that are used to train and test these models.
Exactly. So it's like giving them a giant exam,
Yes. Exactly.
the CNN and VAT, and seeing who scores higher.
Okay. And who won?
So they found that when they trained ViT on this massive data set called JFT300M,
Which, just to clarify, is a monstrously large data set, even bigger than ImageNet.
yes, created by Google,
Right.
they found that ViT was able to achieve comparable accuracy
Okay.
to the best CNNs out there.
Okay, so it's at least as good.
But here's the kicker. It sometimes even surpassed them.
What? No way.
And it did so while using less computational power.
So it's faster and more efficient.
Exactly. Pretty remarkable.
That's huge. But, and there's always a but.
Right.
What's the catch?
There's always a but. It's still, it's a new technology.
Right.
It's promising, but one of the questions is how well does it generalize
Right. Yeah.
to other tasks beyond just,
Right. Beyond just labeling images.
Right. We've been talking about cat, dog.
Right. Exactly. Exactly.
But the world's a lot more complex than that.
It's like you aced the vocabulary test, but can you actually, speak the language?
Exactly. And that's what's so interesting is that the paper hints at some fascinating details about how ViT processes these images,
Okay.
which suggests it can go beyond simple classification.
Okay. Like what?
Well, one thing that really stood out is that ViT, it seems to have a bit of a data appetite.
A data appetite. Okay, hold on.
Yes,
Is
sir.
that like the AI equivalent of a teenager rating the fridge?
In a way,
Uh-huh.
the more data you feed ViT, the better it seems to perform.
Oh, wow. Really?
It's constantly learning and evolving.
See, that's so interesting to me because it's that's such a challenge in AI in general, right? Like getting the data is the biggest hurdle.
Absolutely.
But with this, it's like the more you give it, the smarter it gets, it's just a fascinating, kind of paradox.
And what's even more intriguing is that as you feed it more data,
Yeah.
ViT starts to actually outperform those CNNs that we talked about,
Oh, wow.
even when they're trained on those same data sets.
So it's not just the architecture itself, it's how much it's actually able to learn from the data, which is really cool.
Exactly. It's like comparing a student who just memorizes the facts to one who truly understands the concepts
Right.
and can apply them in new ways.
It's like actually understanding versus just memorizing.
Exactly.
Yeah, that's a great way to put it.
CNNs, they might be hitting a ceiling in terms of how much they can improve simply from having more data.
Right.
ViT, on the other hand, seems to have a lot more room to grow.
Interesting.
So it's learning a much more fundamental set of rules about how these images actually work.
Which, bigger picture, that means it could be way more adaptable in the long run.
Exactly, to different types of images, different types of tasks.
To different situations.
And that's really exciting for areas where we might not have those massive amounts of data, that nicely labeled data.
Right.
Like medical imaging,
Oh, yeah.
where every scan is unique, or scientific applications,
Right, where you just don't have the data.
where data is really valuable.
Yeah, that makes a lot of sense.
So yeah, it's a really cool insight.
Okay, but I'm still stuck on this seeing thing, right? We talk about the squares and we talk about the attention, but what is it, how is it processing those patches to actually understand what it's looking at?
Right. It's one thing to divide it up, but how does it actually make sense of it?
Yeah, exactly.
And remember, we talked about ViT treating these image patches like words.
Yeah.
Well, just like words in a sentence have an order, these patches have spatial relationships within the image itself.
So it's even though it's doing it all at the same time, it's understanding that this one is in the upper left and this one's in the bottom right.
Exactly. Exactly. And what's even crazier is that ViT actually seems to learn this spatial information on its own.
What? No way.
Yeah, the researchers found that it learns to actually encode the relative positions of these patches.
Oh, wow.
So it's like it's building this mental map of the image as it goes.
That's wild. So even though it's breaking it down, it still understands how it all fits together.
It sees the pieces, but it also understands the whole picture.
That's incredible.
And there's no layer to this.
Okay, there's more.
So by analyzing the attention patterns, remember we talked about attention.
Right.
They found that ViT doesn't treat all parts of the image equally.
Okay.
It learns to focus on different regions depending on what it's trying to do.
So if it's trying to figure out if it's a bird, it's going to look more at the feathers and beak area, not so much the background.
Precisely. It's like it learns to hone in on the visual cues that matter most.
Oh, that's really cool.
And what's even more remarkable is that different parts of the ViT model seem to specialize in different types of attention.
Okay, wait, now you're just showing off different types of attention. What does that even mean?
So they found that some parts of the model, particularly in those earlier layers, they're focused on very specific localized features within a patch.
Okay.
Almost kind of like how CNNs operate actually.
So some parts are acting like the CNNs, looking for those fine details.
It's this fascinating parallel. But here's where it gets even more interesting.
Huh.
Other parts of ViT, particularly those deeper layers, they develop a more global view.
Okay.
They're looking at the relationships between patches across the entire image,
Oh, wow.
connecting the dots, if you will.
So it's like having a team of experts,
Yeah.
right? And some are like really focused on the fine details,
Yeah.
and then others are like way up high looking at the whole picture.
Exactly, bringing it all together.
Wow, that is really cool.
It's a beautiful example of how these different approaches can actually complement each other.
Yeah, and no wonder it's so good at,
Right.
understanding those complex images if it can do all that at the same time.
And the researchers really do believe we're just scratching the surface here.
See, now you're just getting me all excited. Like, what are the possibilities here? Where could this go?
The possibilities are huge. Like you said earlier, ViT can get these amazing results with even limited data.
Right.
That's a game changer for things like medical imaging, right?
Oh, yeah.
Imagine it analyzing those scans,
Yeah.
spotting tiny little details that even a doctor might miss.
Wow.
Or how about robotics?
Oh, yeah.
Robots that can really understand and navigate the world around them.
Interact with it. Yeah, that would be incredible.
Exactly. And then there's video.
Oh, right. Forget pictures. What about videos?
Moving beyond those static images.
Yeah.
Imagine ViT learning from hours of footage,
Yeah.
understanding actions and events as they happen.
Oh, my goodness.
So many possibilities there.
Okay, wait. My brain is like officially blown. There was one more thing in the paper I have to ask you about this, okay?
Okay.
Self-supervised learning.
Ah, yes.
What is that?
It's a hot topic, that's for sure.
Now, right now, we have to feed it all this labeled data, right?
We do. Tons of it.
Which, as we've already established, it's hard to get.
It's time-consuming, it's expensive, it's a lot of effort.
Right. But self-supervised learning, it's like, what if we didn't have to do that?
Exactly. What if the AI could learn without those explicit labels?
Like, it just figures it out on its own.
Like a child exploring the world.
Right.
Right. They're figuring things out through trial and error, observation,
Yes.
not by being told what everything is every step of the way.
So instead of me saying, that's a cat, that's a dog, that's a dog, it's like, no, I got it.
Exactly. It can figure it out. And, the researchers, they only kind of touched on this with ViT.
Oh, okay.
But those initial results are promising.
Really?
Imagine a future where these models can learn from any image, any video, without us having to do anything.
That's incredible.
That's the power of self-supervised learning.
It really is like, okay, big picture, if we had to like sum this all up, what does it all mean?
I think the biggest takeaway here is that ViT isn't just, like a small step forward.
Right.
It's a potential, paradigm shift.
Wow.
It's a fundamentally different way for computers to see and understand the world around them.
That's incredible.
And the potential impact, it's huge. Healthcare, transportation, entertainment, really, the sky's the limit.
It really feels like we're like at the beginning of like a whole new chapter.
It really does. It's an exciting time.
It's exciting. It's maybe a little bit scary too.
Laughs.
Maybe a little bit.
But definitely exciting. Well, on that note, the future of seeing, for both humans and machines, it's going to be fascinating.
For sure.
Thanks for joining us for another deep dive, everyone.